Actually, let me try, let's see, let's do an easier one this time. So this one looks interesting. Let's do this one. So we have a cyclic quadrilateral ABCD, and O is the circumcenter. And so yeah, thanks for that solution. That was a hard one. So then the circumcircle of OAD intersects AC. So let's try to draw it like this. So OAD, we want to see where that intersects AC at a point X. And XS is parallel to CD. Okay. And that's on BC. So this is S, and N is the midpoint of AS. All right, so this is N, and we want to show that XN is tangent to the circumcircle BXC. Okay. All right. Is this the best way to draw this? I'm not sure. I kind of like that. So yeah, AOD is isosceles. So we could try to show angle NXC is angle maybe it's worth drawing this point. Show angle NXC equals angle XEC. We know ON is perpendicular to AS. Is ON tangent to the circle? I don't think it is. Because what if we moved yeah, I don't think ON is tangent, although, however I move the diagram, it almost looks like it is. But like here, yeah, it's not tangent, but it's close. It looks like it. Yeah, this problem's so asymmetric. It's like you try to see where AOD meets AC. It's very weird. Oh no, this isn't perpendicular because yeah, NS is not a, I don't know why I thought that. Yeah, AS is not a chord. So XN is a median. Would it help to, is there a symmedian that we could draw? So N is the midpoint of AS. We could also draw the midpoint of AD. So these are collinear and NG is parallel to BD. No, that's not right. NG is parallel to DS. Are D, O, and S collinear? Yeah, no. I wanted a problem that was super easy. This one looks like, I don't know how easy this one is. So we want to show NXB is BCX, which is BCA, which is BDA. Yeah, is there any other triangle where we could have similar triangle to SAX maybe? So AS, it almost looks like, okay, yeah, for a second I thought these were all parallel, but they're not. This problem is just so asymmetric. Like that's what makes it hard. So GN is parallel to DS and XS is parallel to CD. Maybe those two parallel lines could give us similar triangles. So like if we extend GN to meet CD, OX is perpendicular to DC. That's interesting. So that means H would be the midpoint of DC. That's weird. Wait, so wherever point C is, so okay, because point B is kind of irrelevant to that. Like if I move point B around, point H stays the same. So that must just be an easy angle chase, right? And then GH is parallel to AC. So we have a lot of parallel lines. Yeah, it's just an angle chase. Okay. So obviously this is cyclic. Are these concurrent? It's probably a coincidence, but yeah, they're not concurrent. So yeah, this circle is tangent to this circle. So we could try to show angle NXA is XBC. I wonder. No, this don't concur. So let me check some angles here. Actually, let me check this. So NXA. I want to show it's XCB. Or XBC. I think that's going to be kind of hard to do because this angle is not this angle. And if I draw this and this, can we use right angles? Let's see. What happens if we try to draw this circle? I don't think that does too much. What if we draw the parallel to NX through S to try to use that midpoint? So AX equals XI. I mean, basically these triangles are homothetic. And so we want to show that this angle, SIA, equals XBC. Oh, that's kind of interesting. So we want to show angle SIA equals XBC. But SIA, so basically we want to show SICJ is cyclic. I think that's what we want to show. Maybe not. Let's see. Oh yeah, okay. So it's equivalent to showing SICJ is cyclic. That lets us get rid of point n. So we want to show that xi times xc is xs times sj, and xi times xc is xa times xc, which is just the power of x with respect to this big circle. So yeah, basically we want to show x is the same power with respect to this circle and the whole circle. We could also draw this circle if we wanted. So we want to show x has the same power with respect to these two circles, this one and this one. I mean, really, we could do any circle through S and J, right? So I don't know if that's the best one to use or. You guys want to keep working on this, or do you want to try a different problem? Let's try a different one. Oh, okay, you want to keep doing it? All right. 10 more minutes. Okay, so the power of x with respect to the big circle, that's xo squared minus the radius squared. And the power of x, we want to find xs times xj. What's the best circle to use for that? What's a good circle that goes through S and J? We could try this one, this one. I guess since XO is perpendicular to CB, maybe this one would be good because not necessarily. Hmm. I like this idea, but yeah, I have to use that AX equals XI. And then yeah, I guess the benefit of this proof, so that's just the power of X with respect to this circle, and I need to show it's XS times XJ.
I have a proof.
Okay.
Okay, so let's analyze it a little bit. So we need to prove that angle NXB is equal to angle BCX.
Okay, so BCX is something X NXE. Okay, or
BCX
180.
is yeah, so we need to prove that NX is the tangent. So it's the same as saying that NXB is equal to BCX.
Yes, yes.
So BCX is equal to BDA.
Okay.
So can you let BX meet the circle at a point K?
Yes. So BX meets the circle at a point K.
Yeah, circumcircle B, A, B, C, D here.
Okay.
So we need to prove that BXN is equal to BKA.
Okay.
Which means that AK is parallel to NX.
Okay.
So can you delete all the unnecessary circles and lines? Like
Yeah.
just keep A, B, C, D, like just keep the original points and point K.
Okay. All right. Let me delete this. And this.
You can delete, yeah, delete E and also H and G.
Right.
So we need to prove that AK is parallel to NX. So I'm letting X as meet AK at a point.
At SX meet AK. All right.
Yeah. Yeah, so if we can prove that XE is equal to XS, then we will have NX is parallel to AK, right? Because we already have NX is equal to NA.
NS is equal to NA. So if we can show, yeah, then that would show they're parallel. Yes.
Oh well, later. I will prove it later. First,
oh, that's the butterfly theorem. Oh, wait.
Yeah, exactly.
Okay. All right.
It's butterfly theorem. Yeah, but you need to prove that OX is perpendicular to.
Yes.
Perpendicular to SE, which is also perpendicular to CD.
Okay. Okay. So basically you showed earlier by angle chasing that OG is perpendicular to CD or OX is perpendicular to CD, right?
Yeah, that is because we have angle. Let me write that.
Okay. All right. I like the butterfly theorem. All right. And let Sx intersect AK at E. All right. Yeah, it's very nice. Okay, so yeah, I'm just going to make room for that part of the proof. So OX is perpendicular to CD. And XS is parallel to CD. Okay. All right. So this means that OX is parallel to XS. And then by the butterfly theorem, XE equals XS. Yeah, 10 minutes was definitely worth it. So X is the midpoint of the chord containing yes, and then by the butterfly theorem, XE equals XS, and that implies NX is parallel to AK. And once we know that, then it's just an angle chase. So then angle NKB equals angle AKB equals angle ABC. Or NXB, I think it is. Yeah, I'm glad you made me wait and not move on to the next one. All right, so I think, is this everything?
Yeah, you got everything right.
All right, thanks. This is cool. All right, so let's try this one. We have triangle ABC and altitude BH. It's probably better to let B be at the top, although I'm not sure. So let's see. So we have BH. Yeah. So that was not bad. And M and N are the midpoints of CH and AB. This is M. And this is N. And then the perpendicular from M to MN. So basically the perpendicular meets BH at T. Whoops. And THM intersects ABC at Z. Okay, so this is T. Oops. And THM intersects ABC at Z. And we want to show that BM and Z are collinear. This is another very asymmetrical problem. So MT and BT. This is interesting. Oh, really? You solved the problem with 10 minutes left. That's funny. All right. So we can calculate angle ZMH as 180 minus ZTH, and we want to show that ZTH is HMB. And so maybe we could use similar triangles somehow. So HBC, so HMB, that's a median in HBC. And we want to show that's this angle. Yeah, we have to use that this is 90 degrees. So this is tangent to the circle because the center of the circle is going to be on MT. So yeah, so MN is tangent to the circle because of the perpendicular. So that probably helps. So BM is a median of this triangle, and MN is a median of this triangle. So because this is tangent, and I'm trying to use the tangency. Yeah, I guess we also need to use somewhere that N is the midpoint. Maybe I can draw the midpoint of BM, and that would help use, and I could use this and this. Oh, do those meet on the circle? No. Wow, that was really close. How do we use that Z lies on this circle? I almost feel like I'd rather let Z prime be this point, like this, and then show that HMZ prime T is cyclic. Like that feels more natural to me. I like showing things are cyclic more than showing that things are collinear. So is this tangent to the certain? No, it's not tangent necessarily. Maybe we could show AH times AT is AM times AZ prime. Because we know, maybe we could draw this point. All right. So I'll make the problem the way it was originally. Let TZ intersect AC at X. All right. So I'm going to delete point E. BM and ABC. Line passing through Z, cut AH. Okay, so you redefined it like this. So basically let T prime and X prime be like this. So I think you did it like this, right? And then you want to show X prime equals X and T prime equals T, right? So yeah, you defined it to be the perpendicular. Okay. We have mx prime times mh is mz times mb. Yes, because this is cyclic. And mz times mb is ma times mc. Okay. So mh equals mc means that ma is equal to mx prime. Okay, so let it meet AH and T prime and X prime. And then BHCX is cyclic. And then we have this. C. And then MH equals MC means that MA equals MX prime. Oh, actually X, like we could have just left X as X if we wanted. I didn't realize that because that's not in the problem. Okay. So NM is parallel to BC. That means M is the orthocenter of T prime X. So T prime M is perpendicular to the X prime, and that means T prime M is perpendicular to NM, and that means that T prime equals T, and that means that so how is M? So once we know T prime equals T, then yeah, that means that BM and Z are collinear. Let me think about that. So T prime equals T, that means that Z prime, Z prime, yeah. So Z, how did we define Z? Oh, BM, okay, so yeah, okay. Let Z prime equal BM intersect ABC. Implies Z prime equals Z. So BM and Z are collinear. All right. So yeah, it was like a way of working backwards. So we have 5 minutes left. So you said you solved a problem in 10 minutes. Maybe we'll solve one in 5 minutes. Let's see. So we have the midpoint of BC. All right, I'll try to draw this as fast as I can. Midpoint of BC. Let's see how fast I can draw this. AT is tangent to the circumcircle of ABC. Oops. The faster I try to draw it, and I make mistakes. TM. AT is tangent. Tangents. Perpendicular. This is TM. And then X is on BC, so that TAX is 90. So then we have a cyclic quadrilateral there. And XT intersects AB and AC at S and K. And then we want to draw the circumcircle of AKS and show its tangent to AM. Okay, so maybe I'll draw it like this instead. Something like that. XT meets, so this is K and S. And here's the circle. We want to show AM as tangent to it. All right. This is tangent. T and TAX is 90. This looks hard. So this is cyclic, right? And let's draw the center. It's the midpoint of TX. Oh, the center of ABC. Yes. Do these concur, these circles? And are AX and E collinear? I think so, right? And it's probably just an angle chase to show that these concur. So yeah, we'd want to show angle MAK is ASX. All right. We could look at this for like 2 more minutes. I won't type it up if we figure it out, but let's see. Maybe BK and F are collinear? No. G, D, and E are collinear. It almost looks like, yeah, that's probably better. All right, I think I'm gonna stop here. Well, this is a lot of fun. So thanks everyone who participated for coming up with all your amazing solutions and solving that one really hard problem. So this was a lot of fun. And for everyone watching on YouTube, thanks for watching. So if you want to join us in the future, feel free to email me at mgreenb801@gmail.com. That's in the description of my video, and we meet every Sunday at 8 a.m. US Central Time. So thanks again and have a great day.